Hello and welcome to Zig Clr update number 6. This is the first update that contains material and features that didn't exist when I attempted to build a CLR engine last year. And so the code that we're going to look at is up here in this corner here. Let's just step through it. We're going to create a variable x. We're going to set it to undefined. Then we're going to set a cond variable, which we'll set to true. And if cond is true, then we'll set it to x, and then we'll return x. If it were const, then the compiler would take this entire if statement, evaluate it at comp time, and completely remove this. But in any case, it's a stand-in for this hypothetical situation where we have some sort of user variable, and the user variable could either be true or false. And if it's in true, we will set this value to 5, and if it's false, it might still be undefined. So let's give this a shot, and we're just going to run it. And here's what we got. So it first complains that we're attempting to use a value that might be undefined on line 9, so that's right here. And it tells us that the conditional branch has a conflicting status at one branch sets.main, so here. So it is able to identify that this is the spot where one branch of the conditional creates undefined and the other branch does define it. And it reminds us that the variable x was initially set to be undefined up here in one branch sets.main. So this is exactly what we want. We have branching analysis depending on all paths of the conditional here. So let's take a look at what the generated code looks like, and it looks something like this. If you are keen-eyed, you'll see that some of the argument positions have changed. I think this makes it much more readable. But notice that there's this interesting thing going on here where we do inst.conbr. So conbr is the instruction that tells us to do a conditional branch. And what we're going to do is we're going to branch here at instruction number 17. And we're going to branch to the true side and the false side here. The true side here and the false side here. And then the true side contains instruction number 13, 14, and 15. So that's what happened to 12, 13, 14, 15, 16. And then on 17, it got sent here. So the con2br instruction partitions a chunk of the instructions that exist inside of the AIR into a true branch and a false branch. And here you can see that the false branch really does nothing. It just it's this intern value to the block, the block value to just be void. That's what this BR is. So it's the BR is the break that comes at the end of this block. What you may not know is that in Zig there's an implicit block being created here. Well, I mean, it's kind of obvious because we have these block symbols, these brackets. But there is an implicit break that happens at the end of this if statement that isn't necessarily that you don't have to write in your actual code. And so here is where we do the store safe action, which sets this pointer, and in this case we know that it's going to be an intern scalar that is not undefined. So to compare the difference between the true branch and the false branch, what you'll see is that in the true branch, we have this extra instruction here where we're storing a value in this pointer at index number 1. So index number 1 is where we've allocated the space on the stack, and in our next bit, what we've done here on instruction number 2 is we've placed an undefined scalar there. And in the case where we take the true branch, we replace this with a scalar that has is undefined false. So this is a defined scalar. Whereas if we take the false branch, that doesn't happen. And when we exit out of the conbr statement, it does a comparison check, and it looks through the entire list of all of the values that exist in our system in the context of our function, and it says, are there any inconsistencies that are intolerable? And if there are, return an error. And so that's what's going on in this case. We are returning an error because here we detect an inconsistency between what happened when we ran the true branch and what happened when we ran the false branch. Now, you might ask, what would I do if I actually needed to have a branch that sets, and also have a branch that doesn't set? So in the situation where you have something which does set and doesn't set, what you kind of want to do is you kind of want to do something like this. So you want to have a variable that is optional and set that to be undefined. And on your one branch, you set it to have a value, and on the other branch, you set it to be null. This is a safe operation, and what I'll do is I'll go ahead and show that to you by executing it. And you can see here, it executed correctly with no errors. And so this particular program, where we've gone through the process of setting it to be an optional value, the CLR checker doesn't regard it as being an error. Okay, so that's what I have for this update. In my next update, I'll probably work a little bit on structs to make sure that all this stuff works with structs, which we didn't have before. And if you like this content, please share and like and subscribe. And if you really like this content, I'll have a link to support below. Thank you very much.